Okay, so now we're going to talk about another concept of object-oriented programming, which is abstraction. So what is abstraction? Again, we have inheritance. For abstraction, we need inheritance. And we have an animal class, which has a talk method, a dog class, which is extending the animal class, and the cat class, which is extending the animal class. So the talk method in the animal class is abstract. What does it mean? It means that we don't know the implementation. Every animal can talk, but we don't know how. Then every class here, which is extending the animal class, which will be an abstract class, of course, every class here should implement, every concrete class here should implement the talk method, which is abstract in this case, and should be implemented here. So let's say an animal can talk. If it's a dog, it will bark. An animal can talk. If it is a cat, it will meow. And then if we have other animals, right, bear, it can roar and whatever it is, right? So this is called an abstraction, meaning that we have an abstract class without the methods without implementation, and we're implementing them in the dog and in the cat classes. Okay, let's code this one. Okay, so let us code the abstraction example that we draw on the board. So let me create here a class animal. And in the animal class, we want to have a public void talk method. But we said that we want the talk method to be abstract. It means that, right, I have to use the abstract keyword here, right? Or abstract modifier, meaning that I don't want to implement this method. So if we have at least one abstract method in our class, then the class also has to be abstract, okay? So now we have an abstract class animal, which has a talk method, which is also abstract. Let me create here a dog class, which will be extending the animal class. So dog extends animal. Dog extends animal. And when the dog is extending the animal class, now we have a problem. If you want this class to be a normal class, not an abstract class, you have to either, you have to implement the methods, or you can also make this class abstract. So I don't want to make it abstract. I want to implement the method. So the method here, talk, which was not implemented, unimplemented, it doesn't have any body, unimplemented. Yes, okay. Hopefully it will be fixed. Anyways, and then here we are implementing it. Okay. So a dog, how is it talking? It is barking, right? But this method here has been specified, has been declared here in the abstract class, but it has not been implemented. So we are implementing the method here, barking. Now a dog is barking, we are overriding. Actually, in this case, we are implementing, but still we have the override keyword, which we can also omit from there, right? It's not a must, but it's good to have the override, the override annotation there. Let me have also another class here, cat. And in the cat class, we're going to extend the animal class. So cat extends animal. And again, here I'm gonna implement, so public void talk. We're gonna implement the talk method here. You see, I don't have the override annotation, doesn't matter. And here we're gonna say, how does a cat talk? It is meowing, right? Now, in the dog class, we're implementing the talk method. In the cat class, we're implementing the talk method. In the animal class, which is an abstract class, we have an abstract method, okay? So again, let's go to the barn. Let's create a class barn here. And in the barn class, here, we are going to create some objects of animals. So main. The first thing that we should know, guys, is that since animal is an abstract class, we cannot create objects of abstract class. So this one cannot be done. Animal A1 is equal to new animal. This cannot be done. Why it cannot be done? Because this is an abstract class. We cannot create an object of the abstract class. Okay, so this is something that we cannot do. Okay, but we can say, you know what? I have an animal A1. And later on, I can create a dog and assign to the variable, right? A1 is equal to new dog. So what I'm doing here, I am creating a dog and I am referring to it as an animal. Also, again, what we're doing here, upcasting, we are doing upcasting when we had in inheritance. We did upcasting when we had polymorphism, and we're doing upcasting now that we're doing abstraction. Why we can do abstraction? Only because of inheritance. So inheritance is the main concept there. Animal A2 is equal to new cat. So we are creating a cat and we're storing it as an animal. So here also we're doing upcasting. You're doing it in 2 steps, you're doing it in 1 step. So let me create an array, animal array. Here I'm going to store, right, animal array. Here I'm going to store objects of animals. It can be dogs, it can be cats, right? Equals to new animal. How many do I want to store? I'm going to store 3 of them. That's why the index will go from 0 to 2, right? There'll be 3 elements inside. So in the animal array, the first element that I want to store there is this dog that I've created, right? Is this dog that I've created. In the second element, or the element with index 1, I'm going to store this cat that I've created. And the third one, right, I can create another element, not create, but in the third element here, I can create a dog or a cat, new dog, and I can store it there, right? So again, here what we're doing, we're upcasting, creating a dog and storing it as a, right, creating a dog and storing it as an animal. So what we can do now, since we have an array, what we do, whenever we have an array, we're going to iterate the array, right? So arrays, we always say arrays are married to for loops. Okay, so we have a for loop here for every element, for every animal inside the animal array. Oops, sorry, for every element inside the animal array. So what do we do here? Since we have an array of animals, every element there is an animal. So that logic is always the same. Get one element there, which is an animal, and then make it talk. Okay, let's get one element and let's make it talk. So these elements here, these animals will talk depending on whatever they are. If they're a dog, right, let us debug it. Let us debug. So we get the first element from there. Let me see if it's a dog or a cat. Let me hover the mouse. It's a dog. I know Java knows it's a dog. But right, when we're running this one, we are seeing that it's barking. We get the next element, it is meowing. We get the next element, it is barking. So why are we able to call the talk method on the animals? It's because we declared the talk method here as an abstract method, right? If we didn't have this one here, we wouldn't be able, even if the talk, right, if we had a talk method here and the talk method here, and if we didn't have the talk method as an abstract method here, we wouldn't be able to call the talk method on the animal. Okay, so this one is happening because of abstraction. Okay, so hope that this one made sense. See you again.